Assalamu alaikum, this is Team MindTrace. We're directly going to jump into our infrastructure and tech stack. For backend, we're using Spring Boot and its related technologies. For frontend, we're using Kotlin. For deployment, we're actually using a VM from Azure, and for our container registry, we're using GitHub Container Registry. This is our infrastructure architecture. Here, this is an Android user who is sending requests to a reverse proxy, which is a traffic reverse proxy. The traffic reverse proxy is actually sending a request to a backend server. We're using monolithic architecture, but we're actually ensuring horizontal scalability. For that, we're actually using caching. For caching for Redis, for example, for OTP storage and for our AI agents chat memory, we're using Redis. That's why we're getting a horizontal scalable system. For our main database, we're using Postgres database, and for our embeddings, we're actually storing them in Quadrant. A big part of our app is sending reminders. For that scheduling reminders, we're actually using RabbitMQ. RabbitMQ is sending the notifications via Firebase messaging service. For monitoring, we're using Prometheus. Prometheus and Loki is actually collecting the metrics and logs and sending them to Grafana. We also have a node exporter which is collecting metrics from the VM and sending them to Grafana. And in Grafana, we have two dashboards. The first dashboard is Spring dashboard, which is showing our Spring, our request and other things. And we can see here, if we jump back 30 seconds, we can see the logs and also the frequency of the logs here. Another dashboard is the node exporter dashboard. Here we can see the CPU usage, the RAM usage, and everything else. The entire infrastructure is actually deployed with Docker Stack inside an Azure VM.
We have built a full CI/CD pipeline for our project. The pipeline is as follows. A developer cannot push directly at to the main branch. This is disallowed from the branch rule. Instead, how a developer codes is he has to create a branch. There he can edit the code, and then he will create a pull request to merge with the main branch or the dev branch or whatever. And when he wants to merge, when the pull request is submitted, even before he can merge, some tests will be run. If the tests fail, then the developer is not allowed to merge, and a notification is sent to the developer where he will be notified, and he can then repeat the process and code again and submit another pull request. If the tests pass, however, he can merge, and in case he doesn't even wait for the tests to run completely and successfully, if he wants to merge even before that, it is disallowed, and this is written in our branch rule. So this must run and must run completely and successfully. Only then he can merge, and when the merge happens, all the other developers including him can pull from the main branch to get the updated code. From there they can create different branches and edit the codes and so on. How a release system works is when the release is created, a Docker image is built, and that image is of our backend. The Docker image is then pushed to GitHub Container Registry. From there we take that image and deploy to our Azure VM. That's our full CSE pipeline.
Developing a complex healthcare app like MindTrace came with some serious technical challenges since we are handling real-time interactions and sensitive patient data. Let me walk you through how we tackled three key areas: chat memory, Spring AI integration, infrastructure deployment, and security. First, our conventional AI needed fast and scalable chat memory. The default Spring AI options were cutting it. In-memory wasn't scalable, and database storage was too slow. So we built a custom Redis-based chat memory. It gives us high-speed access for conversations and scalable horizontally across servers, which is critical as our user base grows. Secondly, Spring AI was still new when we started, with limited documentation and outdated examples online, so we committed to mastering the official docs. That deep understanding helped us build a stable and future-proof implementation, even in a rapidly evolving system. Third, Infrastructure. It was our first time deploying on virtual machines, and we needed both security and reproducibility. We enforced strict SSH key policies and used Ansible for infrastructure as code. That means our server setups are version controlled, reproducible, and less prone to error, perfect for scaling or disaster recovery. Security and privacy policy were non-negotiable, especially with healthcare data and elderly users in mind. Our multi-layered strategy included: suppose secret management. We use Docker secrets during deployment and Azure Key Vault in production to securely manage credentials and API keys, keeping them out of our codebase entirely. We have OTP verification for caregiver management. We have short-lived QR tokens for patient and caregiver registration or adding them. Secure Telegram notification. We have email authentication also. Distroless Docker images. And finally, minimal permission auth flows to reduce vulnerability exposure. Together, these measures ensure MindTrace isn't just functional, it's also secure, scalable, and trustworthy for sensitive healthcare use.